Please join. Continuation. We have to discuss on the properties or what you call as features or what you call as characteristics. Put together we have 13. And you remember the last one? We already discussed the last one. What is about the last one? Change of origin and scale constant. Whether the measures are affected by change of origin or scale. So we have discussed this in very much detail. So I'm not dragging the time for this. So let me go for the other properties or characteristics. Here, slightly make a small correction, comparison between measures of central tendency and word dispersion. Okay. Uh, First one, let me go in detail. Then I'll give you some small time gap so you can understand in a better sense. Under mean, we'll be discussing arithmetic mean, geometric mean, and harmonic mean. Median we have, mode we have. So these are covered under averages. And dispersion, we have four measures of dispersion. These are the measures, which means these are the measures and these are the properties. Whenever you read this property, ask a question. Is the measure well defined? Okay. Second one. Is it easy to calculate or simple to understand? Just try asking the question. Okay. First one. Is it well defined? What do you mean by well defined means you have a proper definition and you can understand what it's talking about. Okay. So if you go for the three means, arithmetic mean, geometric mean, and harmonic mean, yes, is well defined. Median also well defined. But what happens in the case of mode is no, because we are not getting proper definition, which means by location we find out. Probably you remember this problem, our very first problem. What is mode here? Each and every value is repeated single time. So we cannot talk about mode. Same number of repetition. Mode is something highest frequency. Here we have same number of repetition. See, whenever we are discussing all this property, kindly have the formula. What's the formula for arithmetic mean? Summation x by n. Geometric mean. Nth root of product of all the values. x1, x2 up to xn. What about the harmonic mean? N by summation 1 by x. Median, size of etc. Mode. Usually we go by location method. When the number of observation is small, then we know that we have to go. We use empirical relationship. Is it okay? Is it well defined? Whether the range is well defined? Yes. Yes. You find the largest values, find the smallest value, subtract. It's quite very easy. Quartile deviation also yes, but what about mean deviation? Mean deviation about A we say. A can be mean, A can be median, A can be mode. So it's not properly defined. So if I ask you to find mean defined, we assume that we are going to find mean defined about mean only. But it's not so. I can find it for mean, she can find it for median, one another person can find it for mode or whatever it is. Standard deviation, yes, it's well defined. Okay. So second point, is it easy to calculate and simple to understand? Arithmetic mean by formula is very easy. If I ask you to find mean, which mean you'll find? By default, we'll go for arithmetic mean. Because geometric mean, obviously you'll ask me how to find the square root, which means nth root. Okay. And harmonic mean usually will go by 1 by x. And still we sometimes don't have the clarity why we are taking 1 by x. And you remember the egg problem? You can take this as an assignment. Okay. You take that egg problem. So only arithmetic mean is properly defined. Geometric mean is not properly defined and harmonic mean is not properly defined. When you go for median, yes, it's defined. Mode, probably we have so many methods. One first method we use is by locating it, location method. Uh, Location method is properly defined, but still if we go for grouping method, we don't know why we are making so much of group. Actually, why we are grouping means we are trying to bring as clusters and group it together. That's why we are trying. But again, it becomes a problem. Why we have to do so much of grouping? Okay. Range is defined because L minus S. Quartile division is defined. Mean deviation, sorry, not definition, is simple to understand and easy to calculate. Yes. What about standard deviation? Again, we worry. We take the square root, we take summation of the deviation taken from the mean, then divide by n. Why we have to do so many things? Okay, it looks like okay, it's there in the exam. We get 2 marks and we do it. Okay, so for any other purpose we are working with, we are not really very well known about the concept. Okay, so we're lagging the awareness of this concept. Okay, probably it's not covered in our syllabus. It's over there. Why do you have to take care of all these square root and etc. and all? I have discussed something related to properties, right? When you take x minus x bar the whole square, it will be minimum. That's why standard deviation is quite famous compared to other missions. See, one thing you have to For all the 13 properties, one thing you have to take in your mind. Mean, and that is mean is arithmetic mean. Arithmetic mean and standard deviation are the two measures which will be suitable for further analysis. So we collect the data, we classify the data, we represent the data, then we go for analysis. Doing analysis, not just finding mean and standard deviation. Apart from all the measures of averages and dispersion, we go for the next level. That may be for sampling, that may be for hypothesis testing, that may be for analysis of variance, anything it can be. For everything, standard deviation will be best measure, not also better. Best measure for measures of dispersion and arithmetic mean for measure of average. So this is the second one. Third, is it based on all the items? Ask a question. Is it based on all the items? Yes, obviously yes. Arithmetic mean because we have to add all the value and divide by n. Geometric mean also we are considering all the items, but what happens is if any negative value is given, we have to leave that and check. Because negative value means you'll get imaginary number. You remember? I was discussing this one. I square is equal to root of minus 1. So if four values are given, 3, 6, 48, 24, we can find the geometric mean. What happens if minus 3 is given? The imaginary value. Again, it's again a problem like, okay, actually it's based on all the items, but we have this issue. What about harmonic mean? Yes, it's based on all the items. If one value happens to be 0, for 1 by x, what I have to do? I have to take 1 by 0. It's not the proper format. Okay, probably can strike out. This is only positive values you can strike out. You cannot consider 0, which means you can consider only positive values. You cannot consider 0. Okay, no zeros. Okay. What about median? It's not based on all the items because median itself says the middle value. Okay. Mode, only the highest repeated value. So not based on. Range, definitely L minus S, not based on. Quartile deviation, again not based on. Mean deviation is obviously because in each and every value will take the deviation from X bar. Then divide by L. Standard deviation for each and every value of X we take. So mean deviation and standard deviation, yes, it's based on all the items. Okay. Let me go for the fourth one. Is it capable of further mathematical treatment? Probably yes. Almost all the cases, 99% of the cases we use arithmetic mean. 99% we use standard deviation. Apart from that, geometric mean will be using in the case of index numbers. You remember, you might have done Laspere index, Pache's index, Fisher's ideal index. If you don't remember, we have the index topic. We'll discuss that later. Okay. In that, we'll be using index number. Have you ever thought that you go to a doctor. First thing what they'll check, your height and your weight. And they'll ask you the age. See, age is one separate variable, one factor. Height is another factor. Weight is another factor. All these factors are interlinked. If you go for a height and weight chart, you will by default you'll get a chart where age, height, and weight will be there. For male, for female. See, gender is also variable. But obviously, when we talk about mean, median, and other dispersions and all, we have to discuss only quantitative measures. So we'll not talk about gender-based variations. Okay, so what happens is index numbers and all, we have to go for geometric mean only. It's better comparatively comparing that geometric, what arithmetic mean and harmonic mean. Geometric mean is better. Likewise, we use harmonic mean also for speed. We have to use harmonic mean. Okay, then for what is this one? Mean. It's only used in mean deviation, and we don't have this concept called as combined median and all. Okay, and mode definitely not. Okay. What about range? Actually, no, but in some cases of quality control, stock market fluctuations are all we used the range. For example, if you want to check the weather forecast, they'll show the minimum value and maximum value. They'll give you the range. It's between these values only. Our temperature will be like. Quartile deviation will not use it. Mean deviation, yes, some economists and businessmen are using in their public reports to give some proper interpretation, like they are using it. And yes, obviously, there is a strict yes for both X bar and standard deviation. We use it. That's why we are going to take this as a better measure. I'll go for the fifth one. Let me finish off the 6 points, then I'll give you some time. Fifth one, is it a good basis for comparison? Please ask the question. Is it a good basis of comparison? Actually, we're not going to discuss much in detail, but instead we say this is a good measure for comparison and this is a good measure for comparison. Okay. Sixth one, yes. Is it necessary to arrange the data? When you arrange the data, only in the case of positional average you arrange. Which is a positional average? Okay, that's median and other things. Actually, when we talk about mean, other means and mode, you need not arrange the data. Okay, it's not necessary. Only for median you arrange. And here we are not going to discuss, not on discussion. Okay. So we have the six properties altogether. Totally 13. I have completed first six. You can please have a look here. Please try. Seventh point. Is it affected by extreme values? What do you mean by extreme values? Okay. Kindly join with me. 3, 6, 48, 24. What is the X bar? We have already done this problem. 20.25, huh? The very first problem. If it is, instead of 3, it's 30. 6, 48, 24. Value. We have to use the calculator. Value. 30 plus 6 plus 48 plus 24 divided by, we're getting 27. One more case. 3, 6, 20, 48. 3, 6, 48, 20. Yes. X bar. Huh? You tell the value. He's now only calculating the summation value. You tell the value. 19.25. Now check. What's a property here? We need to check whether it's affected by extreme value. This is the original data. Okay, kindly join here. This is the original data. Okay. Case 1 is the original data. Case 2 is, instead of, what do you mean by extreme value? What do you mean by extreme value? The end value. Smallest and the largest value. Here, what's the smallest value? 3. Actually, that was 30. What I did, I took it in, by mistake, I took it as 3. Okay. So if I take this as 30, what will be my X bar? 27. See, there's a big jump. But what happened is, here, instead of 24, if I take 20, not the extreme value, in between value, my X bar is not taking a big jump. See, here is 20.25, here is only 19.25. So if the extreme values are changed, then it gets affected. Obviously, right? If I change a single value, there should be a change in mean. Yes. If that mean changes, what do you mean by mean? A representative value. Okay. You can refer the first page of single material. It says that measures of averages are the representative values. So when we say it's a representative value, when I make a small change, the change has to be made. What happens to median? See 3, 6, 40, 24, 48. In this first case, let me write it over here. If I find, see, this is for X bar values. If I find median, yeah, join with me. 3, 6, 24, 48. Median will be lying over here. Okay, that's 15, I think. Okay, here, what happens? 6, what's the value? 24, 24, 30, 48. What happens? The median lies over here. Here, 3, 6, 20, 48. The median lies over here. Okay. See, here when the median lies and here when the median lies, will not find a big change. But what happens here? There is a shift to after 24. Okay, see here also. See, I'm not saying that it's not changed, it's also changed, but not to only to certain extent. Because I'm considering only the median value. I'm not considering the extreme value. In case if I leave off the value 3, what will happen? I'll talk only about the median value. Okay. So, yes, actually, when you talk about geometric mean, not much compared to arithmetic mean, but yes, it's affected by extreme value. Here is also yes. Median, no. Mode, no. Range, yes, because the formula itself is L minus S. Quartile deviation, no. Standard deviation is comparative with respect to standard deviation. Mean deviation is less affected. Affected, but less affected. That's about seventh one. Let me finish off the other points, then I'll give you some time for having a look. Eighth one is precise. What do you mean by precise? I talk about 3, 6, 24, 48. For example, for convenience sake, let me take 1, 3, 6, 24, and 48. What's the median value? I'm getting one value as the median value, which falls in the data itself. Okay. If I add all this value and find the mean value, I'll not get 1 or 3 or 6 or 24 or 48. What was the value we got? Can you tell me the value? Or is X bar? 16 point? 4. See, where is 16.4 here? You say that it's a representative. It's a representative, it should be from the data only, no? Okay. I want a representative from this class. I pick one student. From where? From your class only I have to pick. I cannot pick some other student. That's what they say here. If you talk about 4 or 5 data, you say one value is going to be representative value. You have to take one value from the data only. But what you're doing, you're not able to do that. This happens in the case of all the three means. Median, yes, when the median lies in between two values means you cannot find. Because if you have 3, 6, 24, and 48, we'll get 15 as the median value, but 15 is not there in the data. Okay. Mode, yes, most of the cases we get it right, but not in the case of continuous series. Here will not go for discussion. Ninth one, is there anything you can do by location method? Location method is the alternate name called as inspection method. You inspect, which means seeing that you say it. Okay. There are 50 students in my class. I make them to stand. I need not measure the height. If I ask you, who's the tallest student? You can see just locating again, which means inspecting. Okay, you need not go for a proper procedure at all. You record the student one. Okay, what is his name? What is that? You need not do that. Because by seeing itself, we're fine. That's what you call as location method. Okay, location method or what is called as inspection method. There is such no method for all the three means, but by arrangement, you can find the median value. Mode is very easily located. The first method you use itself is location method. It's not on discussion. Graphical method, there is no such for means for you can use Ojai curve for finding median, histogram for finding mode, and Lorentz curve. We have something called as Lorentz curve. It will look like this. You remember Ojai curve will be like this, elongated X-shaped curve. Whereas if you go for Lorentz curve, you'll find a line over here, and lying above a curve will be above the line, a curve will be below the line. This is how it will be formed. Okay, it's not there in the syllabus, but once it's asked in the exam, you have the graphical representation for absolute measure and is found by Lawrence. That's why it's called as okay. 11th one. If open and class intervals are given, is it possible to calculate the measure? That's a question. What do you mean by open and class interval? Less than 10, 10 to 20, okay, up to 80 to 90, greater than 90. See, what is this value? What is this value? We don't know. But because this is 10 to 20, 20 to 30, 80 to 90, we assume this as what? 0 to 10. We make an assumption. Actually, you should not do that, but still we make an assumption. And this is greater than 90. So we take this as 90 to 100. Actually, we should not do, but to find the value, we do it. So in the case of open and class interval, is it possible for you to find the mean value? No, because this is about continuous class intervals, right? Here, when we go for X bar, what's the formula? You need to know the value of M. Here, M value is 15, 25. Here is 85, okay. What's the value here? 5. But I have made an assumption. It's given less than 10 only. You don't know the mid value. Likewise, greater than 90. I have made the assumption 90 to 100 and I can write it as M value 95. But again, it's an assumption only. I cannot take it for granted. Okay. So that's why for the case of open and class, this is often asked for. For the case of open and class intervals, it's not possible to find all the three means, but median you can find it because it's a mid value. Mode you can find it. Obviously, you're going to leave the other ends about. Okay. Range definitely you cannot find it because L minus is. Quartile deviation you can find it. What about mean deviation? Mean deviation about mean you cannot find it. Mean deviation about median you can find it. Mean deviation about mode you can find it. So what's the formula for mean deviation? Summation modulus of x minus a divided by n. This a can be x bar or median or mode. Standard deviation definitely cannot find it. Okay. So what do you understand from this 11th point? Only if all the data are given, you can go for finding the average and what arithmetic mean and standard deviation. See, that's what we need, right? Without giving all the data, without properly getting all the data, how can you say this is a better representative? You should not say that. So in that way, it's highly, highly positive. It's a very good one. 12th one, is it affected by sampling fluctuation or error? See, we are not talking about population. So far, we are using X bar for arithmetic mean, small s for standard deviation, which means we are not talking about population, we are completely talking about sample, which means the population is there. From that, I'm picking out the samples. Probably that may be 100 in number, 1000 in number, lakhs in number, that you need not worry, but that's a sample. So when I talk about sample, there may be some sampling fluctuations happening or there may be some errors contained in it. So because of the sampling fluctuation, because of this error, is my representative value. The measure is affected. Here they say it's not affected, but still I cannot say it's totally not affected. It's least affected. Let me go for the last one. This is less affected. Okay, this one is not affected. See, generally mean is not affected. Median, yes, is get affected. This also gets affected. All the others gets affected. So in that way, also we say that X bar and standard deviation are the better measure. Okay. So 11th and 12th point says X bar and standard deviation are better measures. Kindly go through the Qness. See, I have a data set 1 which has the value 1, 3 and 5. Okay, 1, 3 and 5. What is X bar? 3. I have set 2, 1, not 1, sorry, 2, 3 and 4. What is X bar? The same 3. See, the values are different, but the representative is same X bar. So to compare which data is better, we discussed on dispersion. Sometimes it happens both the values will be having same dispersion. Both the set of data will be having same dispersion. So in that case, I need to know which is a better measure. So I need to go one step ahead. First layer is measure of average. Next layer is measure of dispersion. Next layer is, with respect to this one, measure of skewness. Skewness is discussing about how far it is symmetrical. You know what is symmetrical? I give a square, you break it. You break it into equal half, which means symmetrical. 50-50 area. Okay. I give a triangle. You break it exactly over here. This is 50%, this is 50%. Okay. I give a curve. Now please take care. I give a curve. You break it exactly in the middle. Middle means what? Median. Exactly in the middle. This side is 50%. This side is 50%. This is what you call as symmetrical curve. So I draw frequency curve. So we have seen histogram, frequency, polygon, and frequency curve, right? I draw this frequency curve. Drawing the frequency curve, I find the median value. If it is exactly dividing is 50% means that is this side 50% area, that side obviously median will divide. What about the other two measures, mean and mode? Will not divide. If mean, median, and mode happens to be the same value at this point, then obviously this is going to divide this side and this side into 50%. So this will be a curve which is symmetrical in nature. But what happens is sometimes my mean will be falling this side. Sometimes my mean will be falling this side. We'll be having different type of relationship. See, when we talk about this curve exactly like this way, you call it symmetrical. Sometimes my curve will be like this way. Okay. Sometimes my curve will be like this way. ஒரு பக்கம் இழுத்த மாதிரி இருக்கும். Okay. If this is the nature, you will not call this as symmetrical. You will call it as asymmetrical. Thus, that asymmetrical is what you call as a skewness. Okay. So skewness is related to how far the curve is being symmetrical. Okay. So the heading here is Carl Pearson's and Bowley's coefficient of skewness. We'll discuss that. Again, for skewness, we have two measures. One is absolute measure and one is relative measure. See, for dispersion, for example, if you go range is L minus S. This is the absolute measure. You remember? And we have the coefficient of range, which is L minus S divided by L plus S into 100, which is the relative measure. Likewise, here also we have absolute measure and relative measure. So what do you mean by skewness? Is the asymmetry or what you call as a lack of symmetry. Actually, this content is not there for CA syllabus, but it's asked in the exam. Okay, but it's there in CMA syllabus. So CMA students, no other go. CA students, if you go and search in the chapter material, you will not find this topic. So don't think that I have handled the class for foundation and asked you to listen. No. Okay, it's not there in your syllabus. I repeat it, it's not there in your syllabus, but asked in the exam. Particularly, this was once asked. Some 3 or 4 questions are asked here, but it's very easy. Can easily manage. So we go for types of skewness. Directly, I'll go for the diagram. See this center line, how it looks. See, I draw some dotted line like, okay. See this line, which I'm drawing a dotted line. See, the slope is somewhat evenly steeping up. Then the same ratio it steeps down. This is a symmetrical curve, which you say not skewed. Skewness means what? Not symmetrical. Not skewed means symmetrical. So not skewed or say this as symmetrical. See this green one. I'll draw lines. See this green curve. Can you find the green curve? It is slowly steeping up, but what happens? Suddenly falls down. Which means what? In the line இருக்குல்ல, the curve இழுத்து வச்சு மாறும். Okay. This is negatively skewed. How you say this is negatively skewed or positively skewed means you take a line. This is zero. This side is negative skewness. This side is positive skewness. See, this curve is elongated this side, which means what? Negative skewness. Okay. Now come for this purple curve. I'll draw dotted lines. See, steeps in a fast manner, but steeps down slowly. Which means what? Positive side is drag. Positive side means what? This side. Positive side is drag. You call this as positive skewness. If it happens to be a symmetric curve, which is no skewness, means the set of value data will be given. If you find mean value, median value, and mode value, all will be same, lying at one point. But if it is a positive skewness, means mean will be greater than median, which will be greater than mode. Negative skewness means it's just the reverse. Mean will be less than median, which less than. Okay. So we have two measures. One is absolute measure. We have three formulas, 1, 2, and 3, which is mean minus mode, mean minus median, or median minus mode. This is absolute measure. Let us go for relative measure. Usually we have so many methods to find the relative measure, but we are using three methods from our syllabus. So one is Carl Pearson's coefficient of skewness, one is Bowley's coefficient of skewness, and another one is Kelly's coefficient of skewness. Actually, we have something called as based on moments. Probably we'll do it for population. It will have like mu1, mu2 values and all. If you have mu1 and mu2, that's on population. So you need not worry, it's not covered in our syllabus. So based on moments also we have, but it's not covered in our syllabus. So we'll go for three coefficient of skewness, first, second, and third. Before this Carl Pearson's coefficient of skewness formula given by Carl Pearson is based on averages and standard deviation. Which means what are the three averages we have? Mean, median, and mode. So in this formula, he considers only the three averages and what? Standard deviation S. Okay, so sigma or whatever it is. So he uses as mean minus mode divided by standard. You remember when we say relative measure is something in fractional form, numerator by denominator. So there is something in the numerator which is discussing on mean minus mode. Something in the denominator which is discussing on standard deviation. I can go for coefficient of variation formula. What's the coefficient of variation? Coefficient of variation formula. Yes, you can refer. I am not conducting an oral exam. You can refer. Coefficient of variation formula. Sigma by x bar into 100. What's the first measure for comparing? Measure of averages. So I found x bar. What's the second measure for comparing? Dispersion. I found sigma. Then I went for comparing. See, even though we have the absolute measure, for comparison, we use the coefficient of the value. That is relative measure. So coefficient of variation is CV is sigma. What was on which basis you're finding sigma for x bar? Which means for this x bar, what is the dispersion? Likewise, for this deviation, what is the value? See, skewness is, see, this is the absolute value, right? Mean minus mode or mean minus median or median minus. So which formula we are using here? Mean minus mode. In case mode is ill-defined, we take the help of empirical relationship and we use 3 times of mean minus median. If we go for Bowley's angle, he is discussing based on not all the averages, only on quartiles and medians. When you go for Kelly's, he is also doing the same thing, but not on quartiles and median, but instead deciles and percentiles. So he takes Q3, third quartile, he takes Q1, then minus 2 times of median value, Q3 minus Q1. What Kelly's did, he did the same thing, but instead of quarters, he took deciles. Deciles are closer, taking almost all the data. If you go for percentile, P90, almost all the data. So instead of Q3, he handles P90. P90 is same as D9. Yes, right? You draw the line. If P90 is here, also D9 is also here only. Okay. Q1, instead of taking Q1, he takes P10. Here, D1. Median is in percentiles. Median is P50. In deciles, it's D5. So minus 2 times of P50 and minus 2 times of D5. And here in the denominator, P90 minus P10, and here is D9 minus D10. You remember we were discussing this decile range and percentile range. Decile range is D9 minus D1. Percentile range is P90 minus P10. So when you go for finding these relative measure, we'll get a range. Range means from where to where the value will lie. In these two cases, the value will lie between minus 1 to 1. So minus 1 to 1. Okay. Minus 1 to plus 1. But when you go for Carl Pearson's, actually the value may lie between minus 3 and plus 3, which is like this way. But most of the cases it will lie minus 1 and plus 1. This was asked in the exam for CA. Okay. Original range for Carl Pearson is what? Minus 3 to plus 3. But in the question, they may be asking what is the mostly expected range of, then it's minus 1 and plus 1. Please pay attention over here. Okay. So that's about the concept. Illustration, I request you to make it as an assignment. Probably you can just have a look. I'll discuss what is there. You just have a look on group 1 data, group 2 data, and group 3 data, and just see what we have done here. I'll just have a discussion. Okay. It's quite simple only. Yes, please. See here. Try to understand the illustration. Size given. Size is a class interval. Okay. 0 to 5, 5 to 10, up to 30 to 32. Obviously, we'll go for taking the mid value. And these are the frequency. We are discussing in three cases. If this is the frequency, the set 1 data, this is the frequency, and this is the frequency. Okay. See how this frequency, if you draw the frequency curve, for this, you'll get exactly the symmetrical curve. For this one. For this one, you will get exact symmetrical curve. You can please check. See, what's the highest value? 70. So 50, 50. See, same. Then you'll get a symmetrical curve. 30, 30. 10, 10. Whereas if you go over here, 10, 90, see steep ups. So which means you'll get steep ups. Then it will go slowly down. What curve is this? Negatively skewed. Okay. What about here? Sorry, this is positive. Positive things. Okay. If you go for here, this side, 10, 20, 30, 40, it goes to 50, sorry, 90, suddenly drops to 10. So which means slowly steeps it up, then suddenly falls. We'll call this as negative side skewness. Okay. See, this is as per the frequency curve, you can locate it. Okay. But what happens if we find the averages? For symmetrical curve, all the three will be equal. So you can find the value and check. You can make it as an assignment. If it is negatively skewed, you will be finding mean is greater than median, greater than mode. Okay, this is negative skewness, right? Positive skewness, sorry. Positive skewness, it's like this. Where is the median? Always it will be in the middle only. Mean is higher value. So mean is over here and mode is over here. So mode is less than median, less than mean. Is it okay? And you go for the other way. This is negatively skewed. Negative skewness means the value should be negative in value. See, you're getting negative value. All the values in negative only. Positive skewness means all the values will be positive only. No skewness, symmetrical means all the value has to be 0. This was asked once in the example. CA foundation, you don't have this in the syllabus, but they ask you to understand what you mean by skewness. If there is no skewness means what's the measure? All the value will be 0. Okay, this was asked once. Okay. So that's about graph you can go through. Here if you check, see this is positive skewness, right? Positive side is dragged. Then you'll find that mean is greater than median, greater than mode. Now check this value Q3 minus median will be greater than median minus Q1. Strictly greater than. So this is also a measure. This was asked once. Q3 minus median will be greater than median minus Q1. Likewise, if you go over no skewness, it will be all equal. It will not be greater. If you go for negative skewness, it will be lesser. See, this is the value means this is median. Here is Q1. Here is Q3. You cannot exactly